From page 350, 348, the first question you've asked me for is number 7. So this says use that part 1 of the fundamental theorem of calculus to find the derivative of g. Well, it tells us that g is the antiderivative from 0 to x. So that whole exploration that you just went through and the lesson from yesterday tells you, do you really have to integrate this and then take the derivative? No, because those processes are going to cancel each other out. So when we take the derivative of this, it cancels that out, and you're left with this function when you input this function x into that. So then that would be the square root of 1 plus 2x times 1, because 1 is coming from the derivative of x. So you should just get square root of 1 plus 2x.
Yep.
Okay? So then let's look at number 15. So for 15, it asks you to go from 3 to the square root of x. So now I'm trying to find the derivative of y. So since this is a constant and that is a function, you'll put that function into here. They'll cancel each other out. You have cosine of the square root of x over the square root of x times
1 over 2 square root of x.
because this is the derivative of that function that we're inputting into this function, which would turn into, this is 15, sorry.
No, you're fine.
Cosine of square root of x over 2x.
Wait.
Square root of x times square root of x just turns into
Yeah,
x.
it becomes
You good with that, Bennett?
Yeah, I thought like it became x, no, x to the 4. I was sort of thinking like not x
Change
to the
it
4,
to
like
x.
the 4th root.
Yeah, and add them. It'd be like x to the 1/2 plus x to the 1/2, which would be x to the 1. Okay, so let's get 43.
Yeah, so derivative of square root of x. You don't, once you plug this into this, you don't, there's no more derivatives at all. You just multiply it.
What's wrong with this that I can't use the fundamental theorem of calculus right now?
So you take this.
We've got these functions. We have to have a constant in this lower integration value. So I'm going to separate this integral, and I'm going to just quickly write it out without showing every detail. Isn't there a constant a value between 2x and 3x?
Yes.
And then we need to rewrite this so that this constant value is in the bottom. So that would really turn into negative
Integral of
a to the 2x of u squared minus 1 over u squared plus 1 du. Plus, then from a to 3x, yes. Thank you. And so now can we use our simple, quick fundamental theorem of calculus? So don't forget your negative here, and you want to input 2x into these two values.
That'd be 4x.
So that's 4x squared minus 1, 4x squared plus 1. I do want to make sure I remember that negative is outside of the entire value. And then also times 2. Plus, and then I'm going to put the 3x into here and here. No, I'm going to go any more. So 9x squared
Yes.
minus 1. 9x squared plus 1 times 3. So I would just distribute that negative and the 2 and distribute the 3, and you can keep it as two separate fractions.
Okay, I really don't want
So negative 8x squared plus 2, is that right? Over 4x squared plus 1 plus,
Wouldn't it be 4x minus 1?
no, you would not
Okay,
distribute
okay,
a negative
yeah.
in the top and the bottom. Remember, that's going to be like negative 2 over 1.
Yeah.
So 27x squared minus 3 over 9x squared plus 1. Yeah, and you just brought it out here and did not distribute it. That's fine. Yes, absolutely. And you could bring the 3 out here and not distribute it. That would be fine also.
Oh, I got negative.
I should distribute.
Yeah, if you did distribute it, make sure you have a positive 2 here, because if not, you distributed incorrectly. All right, and then let's look at 45. Doesn't 45 need to be broken up the same way?
Yep.
So I'm going to break this up into from square root of x to a plus a to x cubed. Those are the two integrals I'll break it up to. Then I'm gonna flip this one, and that would go from a to the square root of x of square root of t sine of t dt plus, and then a to x cubed, square root of t sine of t dt. So now what happens when you put in square root of x into here? The fourth root. So it'll be negative fourth root of x times sine of square root of x times
1 over 2 square root of x.
great, plus,
That would be square root of x to the 3.
yes,
Sine of x to the 3 times 3x squared.
times 3x squared.
Is that AP board gonna expect us to like find a common denominator on some of these? If we do these tests?
If it were open-ended question, they would accept it not simplified fully. But if it's a multiple choice question, then you'll have to look at the multiple choices to decide. Sometimes they do, sometimes they don't. But you should be able to do it and simplify it farther. And I'm okay with you leaving it like this.
Yeah, it's just a little like tedious.
Could we simplify it some more? Could the fourth root and the square root simplify out?
If you wanted to.
Yeah.
It'd be negative sine of square root of x over 2. How does that simplify? You have a fourth root in the top and a square root in the bottom.
Is that
It's
equal
negative
to-
negative
Would it be negative 1/4? So it would end up being fourth root of x in the denominator? Yeah, 1/4, subtract 1/2 would give you the negative 1/4, and that's why it becomes a fourth root in the denominator. And then I would rewrite it as 3x squared out front, so that you don't get that confused with your angle here, sine of x cubed.
Could you multiply the 3x squared and the x?
Sure, you could simplify this some more, because couldn't you take out one of those? So that would turn into 3x cubed square root of x? Sure, absolutely, you could do it that way too.
Well, I was saying more than that, we change the square root to 1/2 and then multiply and add them together.
So you wanna make it all one
So
exponent
like
and use
3x
it?
to the 7/2.
Yeah, you could do it like that also. Yeah, any of those would be acceptable. And you should be capable of doing it any of those ways so you can pick out the right multiple choice answer. Because they may have a multiple choice answer that doesn't involve a fractional exponent. So you need to recognize all of those. Okay, and lastly, number 47.
This, so.
You're close to it.
I forgot. Wait,
You're close.
was Aaron right?
What'd Aaron say?
Square root of 257.
Yeah.
Because I tried everything and I couldn't get it.
And then you look at the answer key?
Yeah, and I was like, how the heck did you get this?
Okay, so it's asking us to find the second derivative of capital F at 2. So if I find the first derivative of this, I'm not going to put in the at 2 part yet. If I find the first derivative of this, what would that give me? What is the first derivative of,
Oh, it's gonna be T. Oh, it's
T.
T.
f of x?
Yeah.
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 Right? Aren't you supposed to put x in the place of t? We just don't have the function explicitly defined.
Because, capital F.
Wouldn't you start with the other one?
No, right now I'm finding the first derivative of this capital F.
Okay.
So the first derivative of this is just f of x.
But then we need to
Times
find f
1.
of x.
Now I want to find the second derivative of f of x, which would be the derivative of this. Wouldn't that just turn into this, where I'm putting x squareds in instead of t squareds? So square root of 1 plus x squared to the 4th over x squared times 2x. And then what value did they ask us to put in for x? 2. So now when I input 2, won't I get 1 plus 2 to the 8th over 4 times 4?
So the bottoms cancel.
So those 4s will cancel out? Maybe you forgot chain rule right here, Bennett?
I think I just forgot to apply the 2 to just anything else. I think I just forgot.
Okay. And 2 to the 8th is 256 plus 1
2d7.
makes the square root of 257.
Mhm.
Maybe
I don't know where
Josh
I got
pressed
this
stop.
one.